Right, let's start with a definition here. An ion is an atom or sometimes a group of atoms that has lost or gained one or more electrons. And this means that my atom or my group of atoms is no longer neutral. So an ion will always carry an overall charge. If the atom has lost electrons, then it will become a positively charged ion. And positively charged ions are also known as cations. If the atom has gained electrons, it will become an overall negatively charged ion. And negatively charged ions are also known as anions. Let's have a look at a simple example of each. So here is a simple Bohr model of a hydrogen atom. You can see the positively charged proton in the nucleus in the middle and a negatively charged electron moving around the outside. So to consider the overall charge on an atom, I need to identify how many protons there are and how many electrons there are, because these are the only charged particles in an atom. Neutrons, remember, have a neutral charge. In the case of the hydrogen atom, I've got one electron and one proton. And given that means I have a negative charge and a positive charge, these two charges actually cancel out to give an overall charge of neutral. And because all atoms will have the same number of protons as electrons, they will always be neutrally charged. So what happens then if my hydrogen atom loses one electron? Well, it's going to look something like this. And now by counting the particles available in my atom here, we have only one proton or one positive charge. So having lost a negative electron, the overall charge on my ion now is 1 positive. And we often show this on a Bohr model by putting square brackets and the charge outside them. And what about if my hydrogen atom gains one electron? Well, the Bohr model is now going to look like this. And by counting the subatomic particles, I can now see that I have 2 electrons and 1 proton. So to consider the overall charge, well, one of my electrons will cancel out the positive charge of the proton, but I'm still left now with one negative charge. So the overall charge on my negative ion is 1 negative. And as before, I can often represent this on a Bohr model by putting square brackets and the charge on my diagram. As a quick reminder of two other important terms here, on the left-hand side, when my atom loses an electron, we've formed a cation, which is a positive ion, and on the right, where we formed a negative ion, we can also call that an anion. Let's now identify some key points for predicting which ions will be formed by which atoms. In order to predict the charge of an ion formed by an element, there are 3 general rules that are useful to know. The first one is that metals tend to form positive ions, and the second that non-metals tend to form negative ions. The simple reason for this is related to electronegativity, and metals tend to have low electronegativity values, so they're not very good at holding on to their electrons. They are more likely to lose them during a chemical process. On the other hand, non-metals tend to form negative ions because they pull very strongly on their bonding electrons, so they're much more likely to gain electrons. If you want to look at these patterns more carefully, you'll find Pauling's electronegativity values in the data booklet. And here is also a reminder of how the metals and non-metals are separated on 2 sides of the periodic table by the metalloids. So if we know that metals tend to lose electrons and non-metals tend to gain electrons, how can we predict the number of electrons that they will lose or gain? To do so, we're going to use another general rule called the octet rule. And this states that atoms tend to gain a valence shell with 8 electrons in total. In essence, this means that they will tend to achieve the same electron configuration as the closest noble gas, or group 18 element, on the periodic table. Let's see if we can apply this rule to some examples. So here is the IB periodic table, And let's first identify some metal atoms and consider which ions they might form. Let's start with sodium. And I can find that in the periodic table, it's number 11, meaning that as an atom it has 11 protons and 11 electrons. Given that sodium is a metal, we know that it's probably going to lose electrons in order to form an ion. And to complete the octet rule, we therefore need to move backwards in the periodic table until we get to a noble gas or group 18 element. And because sodium is in group 1, if I take one step back, I move up to the second period, group 18, where I find neon. So in order to get to that noble gas electron configuration, my sodium has simply had to lose one electron to reach the 10 electrons of neon. And as we saw earlier, if an atom loses one electron, it will now have an overall positive charge, or one positive charge. Let's now try the same predictive process for potassium, which is number 19 on the periodic table. As with sodium, potassium is also a metal, therefore it's probably going to lose electrons when forming an ion. So again, we need to work backwards in the periodic table until we reach a noble gas. And, just like before, if we move back one step, we reach the nearest noble gas, which is argon, that has 18 electrons. So, just like with sodium, potassium loses one electron and then now has the same number of electrons as a noble gas. It's worth noting that this is going to be the same for all group 1 elements. They will lose one electron and end up with an ion with one positive charge. Let's now consider magnesium. Again, magnesium is a metal, so it's going to lose electrons when forming an ion. And if I need to move backwards in the periodic table to find the previous noble gas, this time I'm going to have to lose 2 electrons, or take 2 steps backwards. The first step would take me to the electron configuration of sodium, and then the second step will take me back to the electron configuration for neon, which is our noble gas. So when forming an ion, magnesium is going to lose 2 electrons, and will therefore have a charge on its ion of 2 positive. As a final example, let's consider aluminium, which is in group 13. Again, aluminium is a metal, so we know it's going to probably lose electrons in order to form an ion. So in this case, I need to work back in my periodic table 3 steps before I reach the previous noble gas. So when forming an ion, we would predict that aluminium will lose 3 electrons and therefore end up with an ion of 3 positive charges. It's worth noting here that group 1 metals will always form an ion with 1 positive charge, as you can see with sodium and potassium in our examples. Group 2 metals will always end up with 2 positive charges on their ions, as you can see with magnesium. And group 13 metals will always end up with 3 positive charges, as you'll see with aluminium. Let's see if there are similar patterns with the non-metals. Let's first consider fluorine. And given that fluorine is a non-metal, we would predict that it's going to gain electrons when it forms an ion. So with non-metals, we're going to move from left to right until we find a noble gas. In this case, fluorine needs to gain just 1 electron, or move 1 step to the right, before it achieves the 10 electrons of neon. And if the fluorine atom has gained 1 electron, it's going to end up with 1 negative charge on its ion. And actually, considering that all group 17 elements would need to take just 1 step to the right to reach the group 18 or noble gases, we can predict that they will all form ions with 1 negative charge. Let's consider a group 16 element, perhaps oxygen. As with fluorine, it's a non-metal, so it's going to gain electrons, in which case it's going to have to move 2 steps to the right before it gains the same number of electrons as my noble gas neon. Therefore, the charge on its ion will be 2 negative because it's gained 2 electrons. And this will be exactly the same for the other group 16 elements, sulfur and selenium. Well, how about group 15 non-metals, nitrogen and phosphorus? They are both going to need to move 3 steps to the right to reach group 18. so we'll be gaining 3 electrons, and we'll end up with 3 negative charges on their ions. The final element worth considering is carbon in group 14. Although it's fairly rare to find carbon forming an ion, if we were to predict, it's going to need to move 4 steps to the right, therefore gaining 4 electrons and ending up with an ion of 4 negative charges. Let's now try and summarise the key points from this video. Firstly, an ion is an atom or sometimes a group of atoms that has lost or gained 1 or more electrons. We need to know that metal atoms tend to lose electrons, non-metal atoms tend to gain electrons, and we can predict the specific charge on any given ion using the octet rule. And as a final note, for information on polyatomic ions, you'll want to see the separate cohesive chemistry video. Hopefully, this video was of some help.